Great set of topics today. I appreciate everyone coming in right after lunch. Hopefully we'll keep you awake for the next 30 minutes. I did a quick show of hands before most of you guys showed up, but who here is a developer? All right, so we got a few guys in the room that came in a little later. Anyone here familiar with OpenShift? You either seen it or used it before, something like that? All right, awesome. So we'll go a little bit of an introduction to that. And anyone here familiar with Git and use Git on a regular basis? All right, that's why you're here.
There we go.
All right, so quick introduction. So my name is Mike Epley. I'm a solution architect that covers the public sector for Red Hat. And I spend my days driving around the Beltway talking to people, mostly about OpenShift these days. So I'm excited to be here today, talk to a little bit about that. But actually, I do middleware and other emerging technology as well. And I've been doing this for a long time. I was a developer at Lockheed Martin for many years, and basically working in the AI and machine learning space, which was pretty cool, and doing a lot of R&D for them. I'm actually a former lawyer as well. You see some other important vital statistics about me right there as well. So ask me about my bicycles and kids. I love to talk about them. And I have a lot of Legos as well. But unfortunately, I have zero free time, right? Bicycles and kids don't leave you a lot of free time. Anyways, I'll turn it over to Jamie to introduce himself.
Real quick, I was talking to a coworker about this yesterday, trying to actually visualize what 35 cubic feet of Legos actually look like. That's like bin after bin after bin.
Yeah, it's mostly boxes in the basement, unfortunately. But yes, it is an awful lot of Legos. I'll agree with that.
So, as Mike mentioned, I'm Jamie Jones. I'm solutions architect for federal government as well as regulated industries and wherever else in the world GitHub decides to send me. Before coming to GitHub, I was a contractor and developer for the government for over a decade, doing everything from technical architecture, writing code, project management, architecture, going to meetings mostly at the end. But came to GitHub as a way to sort of bring development workflows, configuration management, and technical improvement at a much wider scale. So thank you for coming and joining us today. Hopefully you'll learn something from the talk. We passed over the title slide a second ago, but this is about integrating GitHub and OpenShift together as a way to sort of kickstart and speed up your delivery process, delivery cycle, really make those two tools hum together. Both GitHub and OpenShift on their own can bring massive change to your organization, but we really think when they're brought together in an optimal way, it can really be a force multiplier to your process. So before we get started on the actual workflow, I want to give you a little bit of an overview for GitHub. As a lot of you mentioned earlier, you're used to familiar with Git. Can I see a show of hands? Who in the crowd has a GitHub account? Who in the crowd uses GitHub at work? That's a pretty good amount of hands. All of you on GitHub.com, GitHub Enterprise, both, either, don't know the difference? Yeah, that's fine too. So for those of you who are not familiar with GitHub from a high level, kind of a startup-y vibe from the Valley. We're almost 10 years old at this point, 10 years old later on this year. So we're kind of grown out of being a startup, but we still act like a startup. As they mentioned on stage today, we do over 100 deployments to our website a day, big SaaS platform, over 618 employees in the company, but 59 million repositories hosted, 22 million users on GitHub.com. So we're a really big site that's operating at a very high speed. So those deployments, those processes, of course, have to be pretty fail-proof and foolproof, which is a lot of what we're talking about today. Interesting little fact, we are the 62nd most traveled website in the world, so that's behind like 30 versions of Google and Yahoo and Facebook and the Facebook for South Africa, whatever that is, and all of these other tools. So as we talk about sort of making delivery safe, making delivery secure, that's something to keep in mind. A lot of people, when we talk about GitHub, they think of GitHub.com. Right, which is our SaaS platform. So that's where you can have a personal account or a private account. You may work together as a team, or we have GitHub Business hosted, which brings you the same sort of GitHub functionality with things like SAML and better audit logging. But at the end of the day, it's still in the cloud. So not everyone feels comfortable putting their code, putting their IP in the cloud, especially not a lot of our government customers. They tend to go to GitHub Enterprise, which is the same code base that GitHub.com runs on, except we put it on your servers, or AWS servers, or Azure server, or OpenStack servers, quite frankly, whatever you are already running in your environment. Again, key thing here is it hooks up to your own identity providers. So if you're using Active Directory or Okta or something else, we pull your credentials from there. Like with USCIS, we do authentication via PIV cards. DoD, we do it via CAC, right? So we're using your same authentication methods Do the same thing for auditing. We can send it to your enterprise audit servers, logging servers, to make sure all of your security and FISMA requirements are met. One thing that is key as we go further in this talk, a lot of people think of GitHub as a code hosting platform, right? We think of it as a website. One of the key things I also want to point out is it's actually a platform for doing other operations. We just had one of our big user conferences of the year in London 2 weeks ago, and one of the stats they said is that we get more API traffic, so computer traffic to github.com, than we do people. So think about that. We have 59 million repositories, over 22 million users, and we get more computer-to-computer traffic than we do people traffic. So this API, this platform, is a really big thing as we go forward, because a lot of the integration and things we're going to show you today are built not on the UI, but are built on the API.
Yeah, thanks, Jamie. Appreciate that overview of Git. Now we're going to talk a little bit about OpenShift. So I had asked to see who's seen OpenShift before. And unfortunately, there's a lab right now. So if you wanted to learn more, that would be your best opportunity. So I appreciate you coming here instead. So I'm going to instead give you a quick overview of what OpenShift is and what it does for you. The biggest thing is that it makes your life as a developer easier. The whole point of OpenShift is to automate away all the stuff, all the boring details about deploying, building, managing applications at scale that you would have to do manually and take up all your time instead of doing the fun stuff like coding your applications. So it's mostly a tool to make your life easier. And to do that, we wrap a lot of extra tools around it, things like an API, things like IDE, all sorts of other tools that just make your life easier. We also call it a container management platform. And at its heart, its job is to manage your application in the form of a container. So anyone here use Docker or familiar with Docker containers? All right, a little bit. All right, so I'm not going to go into the details of containers. I'm sure you can learn about that elsewhere. We just don't have the time today, unfortunately. But it's a nice, convenient packaging framework for applications that conveniently separates the concerns of your developers from the concerns of your operations. And the nice thing is OpenShift is going to automate a lot of the stuff on both ends of that. So we're going to get into that, and I'll show you how that works. We're going to see a lot of that automation work during our demo. But you can take a look at some of these other things that it does for you, make your life easier, and then see if it's something that you want to take advantage of. The other thing it does in terms of that automation, though, is build a DevOps process and enforces a DevOps process. So I mentioned that it separates the concerns of developers and operations. And the whole goal is to make it so your developers can focus over here in the code, working in the Git and building branches, building applications in their repositories. And then OpenShift takes over by building the application directly from the source using what we call an S2I process, building and creating your application and containerizing it, and then deploying it in the environment for you. And then finally, managing changes through its APIs so you can redeploy your application or recover from errors or other activities like that. I mentioned S2I. This is actually a key part of that capability. And S2I is essentially the process by which OpenShift containerizes and deploys your application. And at its heart, what it does is it uses what we call a builder image, which is a pre-built Docker image that has instructions on how to build your application from source code. And those builder images are basically designed to work off of Git or an SCM of your choice. And that SCM, basically, the builder image will pull the code from that, usually using a Git clone, and then create the application using the scripts or other tools that are built into that builder image, and then create a final image that can be deployed. And that's the image that is actually your application and the one that you actually interact with. The nice thing about using containers for all this is containers have a lot of nice properties. They're immutable. So when you create an application, you can be assured that that application hasn't changed since you last built it. So when you have to redeploy it or anything like that, you know it's going to work just like it worked before. The other thing that gives you a nice property is those containers and that builder image is also immutable. So your build process is also very repeatable. And if you want to modify that build process or control that build process from an ops perspective for your developers, you can do that and know that that process is going to be rigidly enforced by that container and that builder image. The next thing is it's open source. I always have to plug Red Hat. We're an open source company, so everything we do is open source. The thing, though, that people don't realize is a lot of these open source technologies, like OpenShift, are actually the product of many, many, many open source projects. They're all built and integrated together by OpenShift or by Red Hat. So our engineers spend a lot of time building, and there's probably thousands of open source projects go into something like OpenShift, which is a very complicated project and a very complicated technology. Speaking of which, this is kind of what a nominal architecture of an OpenShift deployment looks like. I'm not going to go into the details of this, the terminology. We'll talk about some of this during the demo. But the important thing is that OpenShift is basically, and I think just like Jamie mentioned about Git, It's an API platform. The management of the applications and everything that happens to OpenShift is controlled by a master. And that master is basically running a bunch of components that schedule and manage the life cycle of your application, the builds, the deployments, and all the other components that are built inside of OpenShift. And that makes it so that you don't have to do that for you. You basically give it a bunch of dumb compute nodes, and it figures out how to utilize those compute nodes and manage the traffic into and out of those applications according to the instructions that you provide OpenShift. The nice thing, though, is that architecture, I showed you a nominal architecture there, is very flexible. You can take that architecture and you can redeploy it or modify it as you see fit. So we have lots of customers that say partition their worker nodes into dev, test, prod instances, maybe deploy those on different infrastructure providers. They might separate out for high availability reasons different components, rely on external providers for authentication and all sorts of other things. Again, it's open source, so it's very easy to control and extend. All right, so next, the other thing is it's polyglot. So I mentioned those builder images. So those builder images are the key enabling technology for us to basically support almost any integration technology that you want to provide in that platform. So we can create these builder images, and this is where a lot of our engineering work goes into, is building these builder images so you can easily deploy applications basically around any language, any framework, or any technology. Containers at their heart are just Linux processes, and because of that, basically anything that you can run on a Linux machine, you can create a container for and you can deploy into OpenShift. And because these containers, again, are immutable, OpenShift and Red Hat can create containers and builder images using proven technologies, QA those, and provide those to our users. And you can know that those containers are going to work with OpenShift and are going to be trusted containers for building your applications. All right, so real quickly, we're going to go into some of the branch and workflow properties that OpenShift can enable. Again, the goal here is to make your life as a developer easier. So we're going to talk about some of the ways we can do that and using Git to control how you deploy applications for that purpose. So the first one that I'm going to talk about, and actually I'm missing a slide here, is just a standard deployment, and I guess I didn't have a slide about that.
We go into that later when we start talking about individual workflows.
All right, very well. So I got rid of that slide or removed that, but probably the first one I'm going to talk about here is A/B testing. So the whole point of an A/B testing scenario is to basically take two different versions of your application, and I mean functionally different, that you want to run some kind of test or experiment against. So you want to be able to route users between those two different versions of your application, send some users to one version, call it the A version, one set of users to the B version, and then compare and contrast the results of those user experiences for some objective. You know, like Amazon, for example, does this so they can see what kind of widget increases their sales, for example. You as a developer might want to do this to see, hey, is this capability actually meeting my acceptance test criteria or something to that effect? And the whole idea is it's transparent to your users. All right, users don't necessarily know what version they're getting, and then they can provide therefore honest feedback to that. But the nice thing is OpenShift enabled this pattern by basically allowing you to deploy these applications essentially seamlessly just by pointing at different Git branches, but keeping everything else about your configuration and environment the same. And basically OpenShift will automatically deploy these things, and then it can configure and control the routing of your users to those A/B endpoints so that, again, it's transparent and controlled very easily. And I'll show you again in that demo how that works. Second common deployment scenario that we can use Git branches for and to control is a blue-green scenario. Now, blue-green scenario, the whole point here is to transition seamlessly from one version of an application to another. And there's lots of different reasons why you might want to do that. Common ones would be like an upgrade or a lifecycle event, where like you just got a new version of your application. You want to transition your application and your users to the new version. Other things might be, well, the exact opposite of that, right? You spun out a new version, and then suddenly you realize that something went wrong, and you want to roll back that version. That'd be a similar blue-green deployment. But there's literally tons of scenarios that you might want to use this for. But one of the important properties of a blue-green transition, again, is your users are not aware of this happening, right? You want it to happen atomically and without them noticing. 1 second you got the blue version, the next second you have the green version. Again, we'll see how that works in the demo. The next very common scenario that you want to use like a branch workflow for would be a canary deployment. Now, canary deployment, and we'll actually get into this in our demo, actually a couple different scenarios worked around a canary deployment, is you've got a new version of your application, and before you let users access that, you want to verify that it's working. Now, the best way to do that, of course, is in a live user and live data scenario, right? Because as we all know, just because it worked on my machine or worked in test does not mean it's going to work in production. So the whole idea behind a canary deployment is you very, very, very carefully let a very small amount of live users into that new version, but you're ready to pull that version back or retract or switch that in kind of like a blue-green fashion if anything goes wrong, right? You either cut off that deployment or you roll it back or something else. Take some kind of corrective action. And that's the whole point of a canary deployment. Think a canary in the canary in the coal mine. And that's exactly what this scenario is named for. All right, so with that, I'm going to transition back to Jamie.
Do you want to do your demo now, or save it for later?
Yeah, I was actually going to do the demo right now. This would be a great time.
Perfect.
All right, so we're going to do a quick demo, and I'm going to show you those different workflow scenarios here. I just got to switch my monitor here. All right, so if anyone has seen OpenShift before,
Speaker.
oh, thank you. If anyone's seen OpenShift before, this should be pretty familiar. And actually, my display should have been already mirrored, but we will fix that here. All right. All right, everyone can see that okay? All right, perfect. All right, so one thing I'm going to note is I'm going to drive this demo using a CLI, and this just makes it fast and simple and easily to be reproduced. So everything I'm going to be doing, I'm going to be interacting with the command line tool using the API. All the actions, though, that I'm doing can be reproduced in the GUI if you want to. Again, just for the demo purposes and to avoid fat fingering or anything, it's all going to be driven via the command line. So the important thing here is to note, if you haven't seen OpenShift before, is this is kind of what it looks like on the front end. And I'm going to go into what we call a namespace or a project. And the project in this view lets you look at your resources and see what they're doing and things like that. And you're going to watch resources as they pop into this as we go through our little demo here. And I'm going to, the screen is a little crowded here. You can kind of see through my terminal. And you can watch resources as they're created pop into OpenShift here. So the first thing I'm going to do is I'm going to just do a generic deployment. And what I'm basically doing is I'm telling OpenShift, go pull my code from a Git repo, and I'll show you the Git repo here in a second as well. And go ahead and build that code using the builder image that I've told it to use, and then deploy that image and make it accessible to my end user. So this was all done with, this is basically like 2 lines of the API. And basically, you see here in the background, and actually I'll kind of make that a little easier to see here. You can see here the application. It's already built. So you can see build number 1 complete. The build, once it was completed, triggered a deployment. The deployment put a container in a pod. And then I created a route to that pod, so I can actually take a look at what that application looks like right now. And we'll see what it is. All right. What? There we go. All right, a little too fast on the finger. All right, but there we go. So that's my application. It's a pretty simple PHP application. It's going to record every hit to that application. And in fact, I can auto-refresh this as well, and we'll do that for the purpose of this lab or this demo, just so that you know, it keeps it live and you can watch it change as it goes. So every 2 seconds, it should be refreshing that. Should be refreshing that. All right, I just might have to refresh manually. Or I've been plagued by poor conference internet all day. So unfortunately, that might be what's happening here. All right, so while that's going though, so I'm going to go back here. And now the next thing I want to do is I want to take my application. I want to create a blue-green deployment of this. Now I'm going to not use this application. I'm going to create a whole new one side by side here. So there we go. So I'm creating some applications again using branches in my Git repo. And you can see here, I've just told OpenShift, clone those repos. I've got a blue and a green, and it's created all the components necessary for that. And I'm going to create them side by side. And this takes just a second or two to build. While that's building, I'll show you my repo here, so you guys can, clone me or fork me on GitHub if you like. It's a simple PHP application. There's some load driving components and other things like that. The important thing is here, I've created a whole bunch of branches. So here's my master branch. I've got a green branch. I've got a blue branch, and I'll have some other branches that I'm using a little bit later here. All right, so my application is built. Now what I want to do is take a look at my application again. Now suddenly I have a blue application. So with the same URL, I didn't change my URL or anything like that. I suddenly pointed my users at the blue application. All right, so that's the instant and atomic cutover. Now I'm going to make it a green application. And we'll manually refresh that. There we go, boom. Took a half a second or so, but suddenly it's green, right? So now I can keep doing that all day long. I can just go back and forth to green and blue and whatever else I want. See if the refresh actually works again. Should be every 2 seconds. There we go, back to blue. All right. So anyways, so as you see, we can easily and rapidly transition between 2 different versions of my application. All right, so my refresh is working. Now let's do an A/B deployment. All right, so just like the green-blue, we want 2 different versions of our application, but we want to route people to 2 different versions of the application, independent or basically depending on some kind of statistic. In this case, I'm going to basically send half my users to one application and half to the other. And if you guys all want to hit my URL with your phones, I'm sure you can run a quick test and run some statistics and see if we're getting that. The point is that half our users now will go to one, half will go to the other. Now, because we have sticky sessions, this one will never change. All right, so our routing is stuck here for this particular user, but if I open up another browser, they would go to another application. And we can do lots of different things with this by controlling the ratio of where we're sending users to. So in an A/B testing scenario, usually you just want a small sample of users going to one application to basically test it to see if it's something that you want a version you want to adopt. And I can do that all day long. I can change that balance, and I can also do things like gradually migrate users from one to another. So if I scroll on down here, you can see I basically told it gradually transition traffic from one to the other. And bingo, so my users will, over time, in this case I'm doing it pretty quickly. Normally you do this over a course of a few minutes, hours, or days even. But you can do that very easily and very quickly here. We'll wait for that to finish up. I think it takes about 10, 20 seconds to finish up. All right, there we go. All right, now let's try a canary deployment. All right. So what I've got is I've got a Git branch out here that's actually going to fail automatically. All right, so OpenShift is going to try and deploy this application. It's actually got to build it first. All right, so I've got another Git branch for canary deployment, and it's got some special code in there that's going to cause my application to fail. And it's going to fail because OpenShift is checking that application when it's deployed to make sure it's healthy. And it's going to say, hey, this application isn't healthy, and it's going to refuse to deploy that. Then I'm going to go in, fix that, push that branch up to Git, and then you'll see that deployment then is replaced automatically for me. All right. So here's my application. All right. So now I said, OK, go ahead and do my canary deployment. And right now, I've got 10% of my traffic going to that, right? So if I deployed that application right now, and let's say that failed, right? Suddenly 10% of my users would have a dead application. But OpenShift is going to refuse to actually start that application because it's going to continuously fail the health check. And eventually, you'll see that thing go red. All did. Apparently, I did not do that right. Or I hit enter too many times. All right. Anyways, let me go ahead and fix this application here. All right, so I'm gonna fix that application. And yeah, basically, I'm cheating. I'm just sending back a bad code here. And I'm going to go ahead and check that in, and let's see if that works. Oops. Hold on a second. Let's make sure I'm on the right branch. What the heck? Commit. Check. Hold on. I'm going to put that down real quick so I can type. No stage files. Good. 502. My 10. All right, so let's push that to GitHub. And what this should do is trigger a new build. Apparently, I hadn't properly reset my demo from the last run. But you'll see it doing a new build, and then it's going to attempt to deploy that new build. And you're going to see that fail. All right. All right, so that looks like it's working this time. It's going to stay, hopefully, in this state for a little while. And you'll see it attempting to build, and then actually I would have done the reverse of the process and unfixed it, and it would have succeeded the next time. All right, so with that, I'm going to turn that over to Jamie, and he'll walk you through some of the next section of our conversation and demo.
Beautiful. So you've now seen a lot of the capabilities that OpenShift provides out of the box, right? You saw the ability for it to A/B test, to just put a little bit of your traffic out to a canary deployment, or even have multiple services and instances running at the same time. So we're going to show you how to really take those capabilities within OpenShift and the capabilities natively within GitHub and supercharge your workflow. So GitHub plus OpenShift is love, is heart, is awesome. So who here in this room has used an SVN-based, commit-to-trunk-based workflow in the last 3 years? You raise your hand. I can raise my hand. Before coming to GitHub, this is what I did with my life, right? I was working on a Navy project, and we committed to trunk. We deployed to a standalone test or QA server, and when we felt reasonably good about it, we pushed that out to production. Sometimes that didn't actually work, and we pushed immediately out to production again. But that's sort of how my life went. When I talk to customers going out and talking about GitHub and talking about modern workflows, I often see a lot more of this, though. We're using branches sometimes. Sometimes we commit directly to master because when there's a security vulnerability, I don't have time to make a branch. Or you know what? This is just one line of code change. We're just changing this color. I don't really need to make a branch. So we see teams sort of pushing to wherever they can. Maybe they're doing branches or maybe they're doing trunk. And then those go to a test server. And then maybe they're using a blue-green style of deploying. So you can see they deploy to green. Then next they'll deploy to blue and vice versa. You're starting to see some of the functionality, but there's a lot of modern steps happening here. So what we've done is we've created a little integration that's actually open source. So at the end of this presentation, I'll give you a link where you can download it and try it out for yourself. But we first start with the normal GitHub flow, right? So everything that makes GitHub easy and useful and successful is using these pull requests, using things like status check, so you can see what your CI is reporting, what your static code analysis is reporting. A lot of what we talk about in Sec DevOps is providing transparency to your entire workflow. So let's first start with the pull request. Let's first start with conversation, code review, and machines checking your work for you. But then let's add in some OpenShift as well. So what we can do, just like Mike showed you, where you can spin up an OpenShift service on the fly, we went ahead and let the integration say, so whenever you create a new pull request, it spins up the service for you automatically. It tags it with the pull request number you're working on and creates a separate route or URL for you to try it out. Every time you get a successful commit, so you see these green check marks, which means all of your unit tests passed, all of your security tests passed, it goes ahead and pushes that out to your OpenShift server. But what's nice is when they don't pass. Maybe you have a code change, or maybe you actually have a security vulnerability that's going to impact your environment. It doesn't go ahead and push those out. So if you have testers, you have security people, you have accessibility compliance people working on this OpenShift service you have running to prepare for the eventual deployment, they're not affected by your poor code writing. And finally, when we get ready to merge that pull request, not only do we go ahead and we do one final push out to your service, but we use canary style. So what we can do is we can start actually routing traffic from the production service to your service that's running for your pull request. This is really helpful because remember we saw earlier where when we did a blue or green, you're actually switching people over from blue to green. Well, this is a situation, you already have the production service running. You already have the test or the pull request service running. You don't need to deploy again. You just need to start changing traffic from one to the other. And at this, you can then, once you are happy with the canary status, you can then start ramping up the load. So again, this is a live integration you can use today. Because Wi-Fi can be difficult, Conferences tend to do that. I went ahead and just sort of screenshotted what this looks like. So just as we walk through this process, we start off with a basic OpenShift application, OpenShift project. We have our production website already running. We go ahead and we create a new branch within GitHub. You can see this branch has a couple more commits ahead of where the master was. It's telling me, hey, you should go ahead and make a pull request for this. If I go ahead and create a pull request, you can see I can outline what needs to be done. I can add some labels as to what's actually happening. And I have status checks running. So right now, my CI server was running as I took this screenshot. When I created the pull request, OpenShift went ahead and created a new service for me. You can see it's created with the pull request number, so it's easy to trace back what's happening, as well as the name of the branch, the color purple, because this pull request was changing the color of the header to purple. So now anyone in your organization, security, accessibility, or even project management can use your OpenShift dashboard to see what's happening in your organization. So it went ahead, created it. Then I went ahead and let CI finish. You can see my CI now has a green check mark. It's complete. So what does my integration tell me? Well, it tells me it's starting a deployment to the staging PR5, and it's currently pending. I give it a little more time, and it's now complete. Not only does this tell me within my pull request that this has been deployed, it gave me a link that I can click on it. That link goes to that same URL, PR5, the color purple.devnation demo. Also, again, you're seeing that some commits failed, status checks did not succeed, so no push to OpenShift happened. However, then I got my build back on track. I got them to pass. You can see below code climate and JS unit were now passing. And of course, my deployment succeeded. One of the other nice things about this, you can see my previous deployment we had talked about is now listed as inactive. Because that commit, because that code's no longer available for anyone to test, right here within your pull request, the integration goes ahead and lets you know. So now anyone can go into OpenShift or your pull request and see the status of your check, see the status of your environment, see the status of your work. Finally, once I went ahead and merged that pull request so everything was good, it went ahead and switched my applications in OpenShift itself. You can now see my PR, the color purple, now has the production URL. The previous production website has the URL of legacy.devnation. If for some reason we do find a bug that we didn't find in testing or we didn't find in the Canary deployment, we can just switch those routes back. You can leave this last service up and running for a couple minutes, a couple hours, or a couple days until you're confident, your security team is confident, and more importantly, your management is confident that this is the deployment you want to stick with. At that point, go ahead, kill that service, retain the resources. But all of this was done without having to touch OpenShift or GitHub at all. Developers just did their workflow. They just did their commits and did their work, and the two tools instrumented everything for you. So as we mentioned, this is a tool that's available for you to download right now. They're taking videos, so if you can't write this down immediately, I'm sure that we can share it later. But it's based on Probot, which is a new open source bot framework that GitHub has developed to make it easier to write integrations on GitHub. I'm super excited about it. If you see me around town over the next couple of months, I'm probably talking about that because I think it has a lot of capabilities to be sort of groundbreaking in how developer workflows happen. Again, this was just a single example of GitHub and OpenShift, but you can imagine GitHub and OpenShift and CloudBees and HP Fortify all taking advantage of these sort of similar workflows. So I know we're almost done with time, but any questions from the crowd? And if not, we're around the rest of the day as well. So happy to take them. So thank you again for your time. Thank you for listening. Let us know if we can help.
Yep. Thank you very much. And if you guys have questions, feel free to hit us up.